In this video, I am going to explain this example. Suppose that the weight of navel orange is normally distributed with a mean of 8 ounces and a standard deviation of 1.5 ounces. Answer the following questions. First, let me define a random variable and note down the given information. Here we talk about the weight of navel orange. Therefore, we can define a random variable x as the weight of navel orange. Now given information, normally distributed mean is 8, the standard deviation is 1.5. So the random variable x has the normal distribution with mean 8 and the standard deviation 1.5. Since the mean is 8, the density curve of this distribution is symmetric around 8. We know all given information, therefore go to the part A. What proportion of orange weight less than 8.7 ounces? First, translate the statement into a mathematical statement. Here proportion, that means probability, less than 8.7. That means probability of x less than 8.7. So that meaning the area under the curve and left of 8.7. Right. What is the first step? To find the probability of x less than 8.7. Convert to the z value. That means we need to find the z value of 8.7 using x minus mu over sigma. Here x is 8.7, mu is 8 and then sigma is 1.5. Therefore z is 0.47. Now using the standard normal density curve, we can show the area, that is the probability of z less than 0.47. Actually, what is the meaning of this? Here the 8.7, the change to the z value, that is 0.47. This z value change keeping the same area. Therefore, probability of x less than 8.7 is equal to the probability of z less than 0.47. Now, can we use the table? Yes, we can. First, check the two conditions. We have z value and also we have less than. Yes, both conditions are satisfied. Again, here we are looking for the area left of 0.47. The z table always gives the area left of z value. Therefore, we can directly use the z table. To find the probability, we check the corresponding probability using the table, that is 0.6808. That is the probability of z less than 0.47. So probability of x less than 8.7 is 0.6808. Without density curves, you can complete this within 2 steps. Probability of x less than 8.7, then convert to the z, then go to the table. So you have the answer 0.6808. Now part B. What proportion of orange weight less than 5 ounces? Yes, very similar to the previous one. Again, translate the statement into a mathematical statement. Probability of x less than 5. So how do we find the probability of x less than 5? First, convert to the z value. We need to find the z value of 5 using x minus mu over sigma. Here x is 5, so we know mu and sigma. Therefore, z value is negative 2. So, now we need to find the probability z less than negative 2. Right. Now check two conditions. We have z value and we have less than part. Yes, both conditions are satisfied. Therefore, we can use the table directly to find the corresponding probability. That is 0.0228. That is the probability of z less than negative 2. So answer is 0.0228. Right. Now part C. What proportion of orange weight more than 11.5 ounces? Here asking more than, that means greater than. Proportion again probability. So asking probability of x greater than 11.5 or the area under the curve and right of 11.5. First step, convert to the z value or find the z value of 11.5 using x minus mu over sigma. Here x is 11.5. Mu and sigma are known, so z is 2.5. 2.33. Using the density standard normal density curve, now you see the area, that is the area under the curve, and right of 2.33. This means the z value of 11.5 is 2.33 and the area must be the same. Right, now we need to find the probability of z greater than 2.33. Can we use the table now? Because we have z value. No, we cannot. Why? We are looking for the area right of z value, which is 2.33. The z table gives the area left of z value. Therefore, we need to change this to the left of z value. Yes, this equal, first we find the entire area and then we find the area less than 2.33, then we subtract. And we know the entire area, it is 1. Then we can find this. Yes, first let me write down this with mathematical notation. Probability of z greater than 2.33 equal 1 minus probability of z less than or equal 2.33. Now you see we have z value and less than part or less than or equal here. Therefore, we can use the z table to find the probability of z less than 2.33. That is 0.9901. Then subtract from 1. The answer is 0.0099. Yeah, these are the steps to find the probability for z greater than some z value. Always. Yes, let me explain again. We need to find the probability of x greater than 11.5, then we convert to the z, then probability of z greater than, then we always write 1 minus probability of z less than or equal that z value, then go to the table, subtract from 1, get the answer. D. What proportion of orange weighed more than 4.9 ounces? Asking the probability or proportion more than, that means greater than 4.9. That is the probability of x greater than 4.9. How do we find this probability? As usual, first step to find the z value using x minus mu over sigma. X is 4.9, therefore z is negative 2.07. Now we can write this as a z value, probability of z greater than negative 2.07. Can we use table now? No. Why? We have z value here, but we have greater than part. So we need to write this as a less than. How do we write this? Always 1 minus probability of z less than or equal negative 2.07. Now we have z value and less than also. Therefore, go to the table directly, find the corresponding probability, that is the probability of z less than or equal negative 2.07, that is 0.0192. Then subtract from 1, get the answer. Answer is 0.9808. Right. Now go to the next one. What proportion of orange weighed between 6.2 and 7 ounces? First, translate this statement into the mathematical statement. How do we write this? Using x, that is the probability x between 6.2 and 7. That means the area under the curve and the between 6.2 and 7. How do we do this one? How do we find the probability or area? What is the first step? As usual, convert to the z value using x minus mu over sigma. There are two values here. First one, x is 6.2. Then next one, x is 7. Now we have two z values. Therefore, we need to find the probability between z negative 1.2 and negative 0.67. As I explained before, these two areas should be the same. That's why the probabilities are the same. Now, how do we find this? Whenever you have two values, or we are looking for the area between two values, we need to find first the left area corresponding to the large value. Here large value is negative 0.67. So we first find the area left of negative 67. Then we find the area left of negative 1.2. That is a small value here, right? Okay, then we subtract. Then we can get the area between negative 1.2 and negative 0.67. So let me write down this using mathematical notations. The probability of z between negative 1.2 and negative 67 equal probability of z less than negative 0.67 minus probability of z less than negative 1.2. Now we have z values and also we have less than for both cases. Therefore, we can go to the table directly. First, find the probability of z less than negative 0.67, that is 0.2514. Now, let me find the probability of z less than negative 1.2, that is 0.1151. Now subtract, so answer is 0.1363. You can complete this one without these density curves. Here you see asking probability of x between two values, then find the corresponding z values, z1 and z2. Then you can write this using z. Then we write down probability of z less than big number minus probability of z less than small number. Then go to the table and subtract, get the answer. Right. Now go to the next one. What proportion of orange weight between 10.3 and 14 ounces? Very similar to the previous one. First, write down this in the notations. Here, probability of x between 10.3 and 14. The first step, find the z values of both numbers, 10.3, first one x and next one 14. Then we have corresponding z values. What is the next step? Then we write the first big number is 4, then probability of z less than 4 minus small number probability of z less than 1.53. Now you see we have z values and the less than part. Therefore, we can go to the table. First, probability of z less than 0.4, less than 4. Actually, using the table, we can find the maximum value. Maximum z value is 3.49. That is the value probability we have. That is the maximum we can go. That is 0.9998. So any z value greater than 3.49, as an example 3.5 maybe, and in our case 4, we always use 1. That means here probability of z less than 4 is 1. So we know it is 1, and now go to the table to find the probability of z less than 1.53. That is 0.9370. Now we can subtract from 1 and the answer is 0.0630.